Welcome to the AS-ROC Severe Weather Analysis for Tuesday, November 25, 2025. This morning's atmospheric sounding was taken at 10 a.m. local time, capturing conditions in the heart of Australia's red centre. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's sounding, we are seeing a classic arid atmosphere over central Australia. The SKU-T diagram shows zero mixed layer Cape, with the blue shaded area revealing significant convective inhibition holding everything down. The red temperature line and green dew point line are dramatically separated, showing surface temperatures of 31 degrees with a dew point of just 8 degrees. That 23-degree spread tells us the air is extremely dry near the ground. With precipitable water at only 24 millimeters, there's simply not enough moisture to support convection this morning. The atmosphere is stable, with a strong inversion at the surface acting as a lid. Now let's examine the afternoon transformation on the enhanced SKU-T plot. As temperatures climb to a forecast maximum of 41 degrees, we see a small area of pink shaded Cape appearing for the surface-based parcel, reaching 373 joules per kilogram. The blue shaded CIN remains prominent, showing the atmosphere is still fighting against convection. The mixed layer parcel shown by the blue dashed line stays suppressed with zero Cape. Allen's discriminant for this afternoon calculates to 82,000. Which crosses the threshold for potential thunderstorm development. However, with such marginal Cape values and very high lifting condensation levels above 4,000 meters, any storms would struggle to initiate. The atmosphere has ingredients, but they're barely mixed together. Looking ahead to tomorrow morning, the machine learning model forecasts conditions remaining subconvective. Cape values stay at 0 joules per kilogram, with the lifting condensation level elevated at 2,780 meters above ground. Wind shear remains moderate at 14.3 meters per second through 6 kilometers, but without any fuel for storms, convection is unlikely. All severe weather indices including supercell composite and significant tornado parameter remain at 0. Tomorrow afternoon shows a slight change in the pattern. The model forecasts Cape remaining at 0, but wind shear increases to 20 meters per second through 6 kilometers. The lifting condensation level climbs even higher to 3,065 meters, making it extremely difficult for any parcels to reach their level of free convection. The forecast remains subconvective, meaning insufficient Cape exists for organized thunderstorms. All threat parameters remain conditional, meaning if somehow storms manage to initiate against the odds, the wind shear would support organized cells. But initiation is the critical missing piece. The multi-parameter evolution chart would show how conditions evolve through the day, tracking Cape, shear, and helicity values. For AS-ROC, we'd see consistently low Cape values throughout the period, with wind shear remaining elevated. The helicity values would stay moderate, indicating wind profile curvature exists, but without buoyant energy to tap into that rotation, organized severe storms cannot develop. This is a classic case of having one ingredient, the shear, but missing the most critical component, the fuel. The hodograph reveals impressive wind shear structure over AS-ROC. The colored wind vectors curve strongly from the surface through 6 kilometers, showing 25.3 meters per second of deep layer shear. The bunker's right mover storm motion vector points toward the south-southwest, meaning if supercells were to develop, they would track in that direction. 1 kilometer storm relative helicity reaches 144 meters squared per second squared, and 3 kilometer helicity climbs to 365. These are supportive values for rotating storms. The problem is, you can have all the spin you want in the environment, but without Cape to lift parcels vertically, that rotation never gets ingested into a storm. It's like having a perfectly curved road but no car to drive on it. The Brunt-Väisälä frequency profile, showing atmospheric stability, would reveal layers where the atmosphere resists vertical motion. For this arid Central Australian environment, we'd expect to see strong stability near the surface where the inversion exists, gradually decreasing with height. The n-squared values help us understand why parcels struggle to rise, even when heated. In desert environments like this, the extreme low-level dryness creates stability that's difficult to overcome, even with strong solar heating. Today and tomorrow remain subconvective over AS-ROC, with insufficient Cape for organized thunderstorms despite favorable wind shear. This analysis is educational only. Always consult the Bureau of Meteorology at bom.gov.au for official forecasts and warnings. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.